What if I told you that right now, at this very moment, China is building structures so massive, so impossibly tall, that the entire Empire State Building could fit underneath them with room to spare? What if I told you they're printing entire houses in less time than it takes you to binge watch a TV series? And what if I told you that by the end of 2026, the construction methods being perfected today will make everything we thought we knew about building look like children playing with blocks? Because that's not the future. That's happening right now. Hey everybody, and thanks for tuning into our channel. My name is Thomas. The future is now, and we are here to explore and reveal all the latest and greatest technological breakthroughs from around the world. Be sure to subscribe to make sure you don't miss out on our daily uploads. Now let us dive in. Let me start with something that just opened in September 2025 that barely made headlines in the Western world, even though it absolutely should have. The Huajiang Grand Canyon Bridge in China's Guizhou province is now officially the tallest bridge on planet Earth. But here's what makes engineers around the world lose their minds. This bridge soars 625 meters above the Beipan River. That's 2,051 feet if you're counting. The deck sits so high that you could stack the Golden Gate Bridge on top of itself 9 times and still not reach the roadway. The entire Empire State Building, from ground to tip, could fit underneath with over 600 feet to spare. Just sit with that image for a moment. But the height is only half the story. This engineering marvel stretches nearly 3,000 meters across what locals call the Earth's Crack, a canyon so deep and forbidding that for centuries it simply couldn't be crossed. Before this bridge opened on September the 28th, getting from one side of this canyon to the other took 2 hours of winding mountain roads. 2 hours of dangerous driving through some of the most treacherous terrain on Earth. Now, 2 minutes. They turned a 2-hour journey into a 2-minute drive. Think about what that means for the people living in this region. Think about what that means for moving goods, for emergency services, for connecting communities that have been isolated for generations. And here's the part that should make every construction company in the world pay attention. They built this impossibly tall, impossibly complex bridge in 3 years and 8 months. 3 years. To put that in perspective, bridges of similar complexity in other parts of the world typically take 7 to 10 years, just from groundbreaking to completion, and that's after a decade of planning and approvals. The Gordie Howe International Bridge connecting Detroit to Windsor, which is nowhere near as tall or complex, is taking over 7 years to build. China built the world's tallest bridge, suspended over the most challenging terrain imaginable in half that time. How did they do it? By using technology that sounds like it came from a science fiction movie. Satellite navigation systems working with drones and smart monitoring equipment to achieve millimeter-level precision in high-altitude construction. Ultra-high-strength materials that can withstand the powerful canyon winds that whip through the gorge at terrifying speeds. Sensors constantly monitoring every cable, every support, every square inch of the structure in real time. During the final load tests in August, they drove 96 trucks weighing 30 tons each across the bridge while over 400 sensors tracked every microscopic movement. The bridge didn't just pass, it performed flawlessly. But you want to know the craziest part? This isn't even China's only record-breaking bridge that opened in 2025. Just 2 weeks earlier in September, the Changtai-Yangtze River Bridge began carrying traffic across one of China's most important waterways. This beast is the world's longest cable-stayed bridge, stretching 10.3 kilometers. That's 6.4 miles of bridge with a main span of 1,208 meters. It's the first crossing of the Yangtze River to carry an expressway, a regular road, and an intercity railway all on the same structure. 3 different types of transportation infrastructure integrated into a single bridge. The engineering challenge here was absolutely insane. Railway systems typically weigh about 3 times as much as roads, so most bridge designs keep everything balanced by placing the railway in the center with roadways split on either side. But that design wastes enormous amounts of valuable urban land because lanes have to loop around, dipping under the railway and merging again. So Chinese engineers designed something that had never been done before on a large-span bridge. They put the railway and the road side by side on an asymmetrical lower deck, then carefully adjusted the cable tensions on the railway side to keep the entire structure perfectly balanced. The result? A bridge that cut travel time between Changzhou and Taizhou from over an hour to just 20 minutes, while using land far more efficiently than traditional designs. these bridges took 6 years to complete. 6 years of solving problems that had never been solved before, of inventing new construction techniques, of pushing the absolute limits of what's possible. And China completed both of them on schedule. Nearly half of the 100 tallest bridges in the world are now in Guizhou province alone. Guizhou now has over 32,000 bridges either completed or under construction, compared to fewer than 3,000 in the 1980s. They've essentially rebuilt an entire province's infrastructure in 40 years, and they're doing it faster and better with each passing year. Let me tell you about something even more mind-blowing, because it's going to completely change how we think about construction itself. In April 2025, a team from China Three Gorges University did something that sounds absolutely impossible. They 3D printed an entire 2-story building in 22 days, using only 3 workers. 22 days, 3 people. An 8-meter-tall, 100-square-meter structure with 15 load-bearing columns and fully 3D printed outer walls. This isn't a prototype or a proof of concept. This is a fully functional building that people can actually live or work in. Think about what traditional construction looks like. Dozens of workers, months of labor, tons of waste material, noise, dust, safety hazards. Now imagine a massive printer 6 meters high and 20 meters wide, methodically building a house layer by layer with almost zero waste. The printers use liquid concrete materials controlled by computer systems for true precision. Every wall, every support, every structural element is placed exactly where it needs to be, with millimeter accuracy. The result is buildings that are not only faster and cheaper to construct, but actually stronger and more earthquake-resistant than traditionally built structures. Researchers tested a 3D printed house model by subjecting it to simulated earthquakes of increasing intensity. At intensity 6, no damage whatsoever. At intensity 7 and 8, some cracks appeared but didn't extend to the structural framework, and the building remained stable. Even at intensity 9, which is devastating earthquake territory, the core structure stayed intact without collapse or severe damage. These printed buildings are actually safer than what we've been building for centuries using traditional methods. And this technology is already scaling up massively. Chinese companies are now producing these structures not as curiosities or demonstrations, but as actual solutions to real housing needs. One company, Huajiang, has developed printers that can construct buildings of any size and shape, including high-rise apartment buildings and structures with unconventional designs that would be impossible with traditional construction methods. Winsun, another Chinese company, printed a 6-story apartment building and a mansion using their 492-foot-long 3D printer. They can build a 400-square-meter 2-story house in 45 days while using 30 to 60% less raw materials, saving 50 to 70% on construction time, saving 50 to 80% on labor costs, and reducing the total price by 50% compared to traditional construction. But the real revolution isn't just the speed or the cost savings. It's what this technology enables in places where traditional construction is nearly impossible. In rural China, 3D printing is being used to improve farmers' living conditions by building quality housing quickly and cheaply in remote villages. In February 2025, researchers tested earthquake-resistant 3D printed houses that can withstand forces that would destroy conventional buildings. The University of Hong Kong created a traditional house of the future in Guizhou province that combines 3D printed construction with timber framing, creating a participatory framework that integrates robotic on-site printing with traditional wood craftsmanship. This isn't about replacing human skill. It's about augmenting it with technology that makes the impossible possible. And construction innovation in China isn't stopping at bridges and 3D printed buildings. In April 2025, the Chinese government approved construction of 10 new nuclear reactors with construction expected to start in 2026. Total investment, 200 billion yuan, about $27.9 billion. These reactors are scheduled to connect to the power grid by 2032. But that's just the beginning. The 14th five-year plan outlined a goal of constructing 150 new nuclear reactors by 2035, with a total estimated investment of 3.1 trillion yuan. That's $432.6 billion being poured into energy infrastructure over the next decade. China isn't just building nuclear reactors using traditional methods either. In October 2025, construction reached a major milestone on the ACP-100 Small Modular Reactor Demonstration Project. This reactor uses completely new technology that's more efficient, more flexible, and safer than traditional nuclear plants. Construction started in 2021. The equipment installation and containment dome building were completed in 2025, and the reactor finished its first cold testing in October, confirming proper installation. It's scheduled to enter commercial operation in 2026. This is the cutting edge of nuclear technology, and China is deploying it at commercial scale while other countries are still in the planning phases. Let me put the scale of all this into perspective. According to the State Taxation Administration, China launched 182 major projects in just the first quarter of 2025, requiring total investments of 340 billion yuan. That's $47.4 billion worth of construction projects kicked off in 3 months. And that's not even counting everything else. In July 2025, China finalized and issued its full list of key construction projects for the year. Total investment? 800 billion yuan, about $111.8 billion, supporting 1,459 projects across key areas, including ecological restoration, transportation infrastructure, high-standard farmland, water conservancy, and urban underground utilities. The numbers are almost impossible to comprehend. China's construction machinery sales rose by 23% year-on-year in the first half of 2025. The construction industry is expected to record an average annual growth rate of 4.2% between 2026 and 2029, supported by investments in renewable energy and transport infrastructure projects. Between January and May 2025 alone, 1.2 trillion yuan was invested in the country's transport infrastructure projects. That's $167.5 billion in 5 months, just for transportation. But here's what all these numbers really mean. They mean that China is building the physical infrastructure for a completely different kind of future. They're not just constructing bridges and buildings, they're constructing the foundation for economic transformation in regions that have been left behind for generations. Guizhou province, where both of these record-breaking bridges opened, is one of the poorest provinces in China. These mega projects aren't just engineering achievements. They're economic development tools that connect remote regions, enable tourism, facilitate trade, and fundamentally change what's possible for millions of people. The Huajiang Grand Canyon Bridge already has a high-speed glass elevator, taking visitors to a cloud-top cafe being built at the top of the nearly 800-meter-high bridge tower. They're installing paragliding, rope-free bungee jumping, a high-altitude speed runway, and a water screen light show. In September 2025, they held the first world's highest bridge triathlon international challenge with nearly 200 athletes from over 20 countries competing on a course that went on and around the bridge. Villages that have been isolated for centuries are now seeing an influx of tourists. Hotels are fully booked. Local economies that had no prospects are suddenly connected to the wider world. And the construction techniques being perfected on these massive projects are spreading everywhere. The same smart monitoring systems, the same ultra-high strength materials, the same precision construction methods are now being applied to smaller projects across the country. The 3D printing technology that can build a house in 22 days with 3 workers is being deployed in rural villages to improve living conditions. The modular construction techniques that can erect a 57-story skyscraper in 19 days are being refined and expanded. Every breakthrough feeds into the next breakthrough, creating an accelerating cycle of innovation. What's happening right now in construction in China is something the world has never seen before. It's not just about building bigger or taller or faster, though they're doing all of that. It's about fundamentally rethinking what construction can be. When you can 3D print a house in 3 weeks, housing shortages become solvable. Problems? When you can build the world's tallest bridge in under 4 years, geographic barriers that have existed for millennia simply disappear. When you can construct 150 nuclear reactors in a decade, energy security becomes achievable. When you can launch nearly 200 major infrastructure projects in a single quarter, regional development becomes a choice rather than a distant dream. By the end of 2026, the construction landscape will look fundamentally different than it does today. The techniques, the technologies, the approaches being proven right now on these mega projects will be standard practice. 3D printed buildings will be common, smart construction monitoring will be ubiquitous. Ultra-fast project timelines will be the new normal. And all of this will continue accelerating because China has built an entire ecosystem around construction innovation. Universities researching new materials and methods. Companies competing to develop better construction technologies. Government policies supporting massive infrastructure investments. Workers gaining experience on increasingly complex projects. It all feeds back into itself, each success enabling the next leap forward. The question isn't whether China will continue pushing the boundaries of what's possible in construction. That's already decided. The question is whether the rest of the world can keep pace with innovations happening so fast that record-breaking projects are opening within weeks of each other. Because while we're still using construction methods from the 20th century, China is already building the 21st century's infrastructure. And they're doing it faster, cheaper, and at a scale that should make everyone in the construction industry around the world stop and take notice. What technology that amazes you the most? We'd love to hear from you in the comments below. And if there are any technologies you'd like us to cover in the future, let us know. We upload videos almost daily covering the latest breakthroughs from around the world, so make sure you subscribe so you don't miss anything. Comment the exact minute I blew your mind the most. Highest voted comment gets pinned and I'll make a full video on it. Thanks for watching and I'll see you in the next one.